Hey everybody, welcome to Mission Control Houston. I'm Dan Huot, Public Affairs Officer here at NASA. I'm joined today by Richard Watson, one of the spacesuit engineers, also here in Houston, working for NASA at the Johnson Space Center. We're here to talk today to Bunker Hill Elementary from my hometown, Middletown, Delaware. Really excited to take some questions from the students there, give you guys a little bit of insight of what we're doing here at NASA these days, and anything else you know, if you're excited about space, we want to know, we want to answer those questions. So just real quick, a bit about the room. We're in the International Space Station Flight Control Room. This is a room that's staffed by people 24 hours a day, 365 days a year. Always monitoring systems, always flying, literally, they're the ones flying, controlling the International Space Station, which actually a lot of you, as long as you've been alive, this is something really exciting to remember, there have been people in space. So really cool fact, since the year 2000, human beings have lived in space, and this is where we talk to them, we monitor them, we help them out through their daily process. So Richard, thank you for joining me here today. I know we're real excited to take your questions, so as soon as you guys are ready, we're ready too.
What is the most important job in mission control?
Hi. Who was that question from?
Tennessee, Harper.
Well, thanks. So that's a great question. So there's a lot of different jobs in mission control. We have folks that are working to go through and actually control the vehicle and its attitude and how it's flying across the sky. There are folks working on the actual environmental control systems that keep the astronauts safe inside the vehicle. There are folks that are coordinating what the astronauts are doing inside the vehicle with their science experiments. So a lot of different jobs, and I think the biggest thing to realize is that it's a team effort, and so to call one person the most important, in some ways it makes it seem like that person does everything by themselves. And there's one guy or girl that's really kind of bringing everything together, and that's the flight director. And so they're probably kind of like the quarterback or the conductor of the symphony that's happening there, but they can't do what they do without everybody else. So there's one person that's really kind of running the show and making sure everything's going smoothly, and that's the flight director. But that person really, what they're doing is really coordinating everybody else. So the team is really more important than any one individual, but that individual is the one that's really responsible for the whole room.
Kind of brings them all together.
Yeah.
All right, great question. Let's move on to the next one.
Hi, astronauts have to train before they go to space. So what type of training do they do at mission control?
Great question. So yeah, astronauts do train. They do several years of training before they get assigned to a flight, just to familiarize themselves with NASA. And they actually train a lot before they even come to NASA, so they're very good at something they do beforehand. But when they actually come in, they're going to go through and see things like how do they get up and down from space. So what vehicle are they going to actually ride in? They're going to go through and get training on the vehicle that they're inside of and how that vehicle operates. And then also not only that vehicle, but also the vehicle, the ISS, that they're going to be operating. So emergency procedures. So what do you do if there's a fire? They're going to be going through and trying to learn about the experiments they're specifically doing. How do they go through and just keep the station running? Learning to do things like just normal things like we take it kind of for granted, like how to go to the bathroom, how to eat, how to change clothes, how to wash your clothes, where do you sleep? You have to do all these things a little bit differently in space than we do here on the ground, and so they get to learn about all of that. Some of it happens in mission control itself. Most of it happens outside of mission control, over in the mock-up simulators, or sitting down with some great folks that train them specifically there. And you want them to learn in the spot where they're going to be operating. So normally it's a place that looks a lot like the International Space Station, and we call it a mock-up that people learn at.
Yeah, and I mean, and it's not just here in Houston, it's an international space station. So these astronauts actually train all over the world. And you got to remember, like Richard said, they'll train for a couple of years. So when they get assigned, they'll train for about 2 years just for a 6-month flight. So it's a lot. It's actually a lot like what you guys are doing. It can be a lot of classrooms, it's a lot of tests, a lot of things like that to make sure they're ready. And they do it all over the globe. So they also have to learn how to speak different languages. It's very difficult, but as they'll all tell you, it's very rewarding once you're up there.
Yeah.
Next question, guys.
Thank you. What are the biggest changes in the new spacesuit?
Great question. So we have a couple of different spacesuits that are kind of on the new side of things. Spacesuits are a little bit like cars, and so like a Toyota Prius and a Ford F-250 truck are both types of cars, but they do different jobs and they do them differently. So I work what's called on the Orion vehicle, and that vehicle is a capsule. And so the biggest thing for that suit is a launch entry kind of thing. So it's going to protect us if the vehicle, for some reason, has something bad happening with it. The new things with that one is how it integrates with the vehicle and how it's comfortable when you're wearing it there, and what it does if you get into an emergency. There's another suit called the Z2 suit, which is more to go walk around on the moon or on Mars, or go do some work outside of the vehicle. So that suit is fun and neat too, and that one it more is trying to be more mobile when you're outside working. So our bodies need some interesting things. We really like Earth as a place to go through and have it protect us down here. So the temperature on Earth is very good for humans. The fact there's oxygen for us to breathe, that's pretty important.
Kind of important, yeah.
And then the pressure itself, it's really scary actually out in a vacuum of space. Your blood essentially boils, which is very dangerous. So you need a suit to go through and protect you from that, or a spacecraft to go help us with that. So as you're protecting though, you want to be able to do useful work. So being able to move your gloves, move your arms and legs, bend down, pick up a rock, move a box around. Those are all things that you want to be able to do, but you also have to protect the person. So working with both of those things together to do the job a little better, so we put different features in the suit to go through and make it easier to move. So that's the biggest things on the new suit, are ways that make it easier to move, and also how we get in and out. So originally right now we kind of have a shirt and pants design on our current EMU, our space station, the white puffy suit that they go out the door in. You pull on your pants, and then you pull on your shirt, and then you pull on your helmet and gloves. The new suit that goes outside would actually have you climbing in a hatch in the back of the suit, kind of like the backpack opens up and then you climb down in it.
That makes it a lot quicker, a lot easier. It's
Exactly.
also a lot lighter too, because I mean, I don't know if you guys have seen it, but that big white spacesuit, I mean, it weighs how many? A couple hundred pounds.
Yeah, about 350 out the door.
And it'll be tough to walk around on Mars with. It's less gravity, but it's still quite a bit of weight.
Yeah.
Yeah. All right, very good question. Let's move on to the next one.
Hi, I'm Matthew James.
Hey. How are you?
So, good, how about you? My question is, how do you like the new look of the Z2 spacesuit?
The new look of the Z2 spacesuit. Yeah, so we actually had a neat competition that some folks got to go through and do, where they went online. They came up with a couple of neat paint jobs for the outside of the suit, and had a lot of people come in and vote on which suit was going to be the one that was the coolest looking. And so they got to pick one of those, and that one came out looking real nice.
Yeah, I remember setting that up because I mean, because you're a spacesuit engineer, or designer, that you don't always get to design something just because it looks cool.
Yeah.
Like first and foremost, you got to make sure it's going to be safe, it's going to work, all that, the boring, but like the stuff you really need. So I remember when it got brought up, they were really excited because they're like, we get to make this. And it can look cool, so it was a really, I know it was an awesome thing for the design. It was a really cool thing for us too. We always love, hearing what you guys think, and letting you kind of have a voice in what we're doing here. So I was really excited with how it came out.
Yeah, and I think they may have some folks in the room there with them actually, Linda Hughes and Jenny Furl from ILC, that actually are maybe helping out, getting to work on that suit as well. Up there. They work on the EMU, so it's pretty cool what they have going on out there in Delaware.
All right. Let's keep it going.
Okay, thank you.
Hello, my name is Casey Stevens, and I was wondering, what is the purpose of mission control?
Great question. So mission control, we're here to go through and help out people on orbit. And so originally, if you actually need somebody commanding things and watching things, because if all the astronauts were doing in space was watching the vehicle, they wouldn't be very effective at going through and actually doing their job up there. So there are some systems that we can sit down here on the ground and monitor and watch for them, and also be working ahead of them a little bit. So you'd like to to when the astronaut goes to perform a task, already know what you're going to do, how you're going to do it, and if something goes wrong, how are you going to respond. So that's mission control is really important because it's thinking ahead. It's going through and making sure everything is streamlined, everything's working properly, anticipating problems, realizing when a problem, if it does come up, is it important or not. There's some things that could come up that we have real good workarounds for that we aren't going to actually do anything. Maybe the answer is, hey, that's okay, we can keep going, but we don't want everybody to stop for a problem that we could just say, hey, we can take care of that later. So that really is the big thing, is going through and making things streamlined, making things actually going to work effectively together on orbit, so that we are able to go through and really use the valuable resources that is time on orbit. Is such an important thing, because it costs a lot of time and money to get somebody up there, and we want them to be effective up there, and that's really what this allows us to do.
Yeah, pretty much do everything we can down here on the ground, let the astronauts do astronaut stuff and the stuff only they can do. So that's a perfect explanation. All right, next question, guys.
What does the new Orion spacesuit do, and why is it so special?
Great question, thanks. So originally what we used in shuttle was a similar suit. That suit worked kind of like a scuba tank that kind of encapsulated your whole body. Basically, oxygen came in just a line that had high pressure in there, and then we breathed on that line, and it vented off into the cabin. It wasn't a part of the original shuttle design, so it was kind of added on after the fact. So it didn't integrate as well as we would have liked with the actual vehicle and the way the vehicle operates. This suit is new because it actually has the ability to keep doing the job like the shuttle suit did, but it also has the ability to tie directly into the vehicle systems to go through and take and deliver oxygen directly to the crew member, but then also pull off the CO2 to pull off the water they're producing as they may sweat, and to go return it back around. So it's really tying it back in together with the vehicle is what's kind of special about this one. We've looked at a couple of different things about different missions we could support, like could you do a spacewalk if an emergency happened. We're not sure if we're going to do that yet, but we're continuing to look at that one. But really the key with this one is trying to protect the crew when it's coming back in, and if you were to go into a crash landing, trying to make sure that they can't get hurt in there is different than we did in shuttle. So the new things about this one are better crew protection on landing and better tying into the vehicle so that we get a system that's lightweight and simple and very reliable is really where we're going.
All right, very, very good question. Very good question. All right, let's go on to the next one.
Hi, I'm Emma, and what happened on the ISS this morning? Were the astronauts in danger?
I'll admit the ISS this morning with the ammonia, so
Oh,
they were.
okay,
I'm
yeah.
going to hand that over to Dan.
Somebody's been following along. No, so early this morning, it was about 3 a.m. Central Time, 4 a.m. Where you guys were, so you're all probably still asleep. I was until I got woken up. We had an alarm go off, and Mission Control is great at monitoring everything that's happening on board the International Space Station. And they have these sensors throughout everything on board. So if something starts to look, we call it off nominal, but if something starts to look wrong, we can get ahead of it. We can make sure the crew is safe. So there are these things called ammonia pumps, and I'll try not to get too, overly technical, but basically all the stuff on the station generates a lot of heat. So we have these lines that take that heat and dissipate it out into space so things don't overheat, basically just keeping them functioning, keeping them safe. And one of the issues with that is ammonia is very poisonous to us, so we have a lot of safeguards in place to make sure the astronauts never get exposed to it, but there's always a chance, and we always prepare for that chance. And so there were some indications that there may have been ammonia getting into the crew's atmosphere. So as soon as we saw those indications, we made sure the crew donned some emergency breathing masks. They went over to what we call the Russian segment, where there is no ammonia used, and they sealed it off. So we can actually seal off each part of the International Space Station with just doors in between each one. So just in case something happens, they can isolate that, and they can still be on the station, and they're still totally safe. So they went over to the Russian segment, they sealed everything up, all 6 of them been hanging out there all morning, and the team here in Mission Control continued to look at all the data. Everything they've looked at so far is indicating that there was no ammonia, so it's probably just a false alarm, but they're still investigating what made that sensor trip and, you know, what led to the pressure change that they saw, which initially led to this decision. But that's kind of where we are now. Right now the crew's still inside the Russian segment, but they're just kind of hanging out, kind of enjoying an unscheduled off day, as all of their science experiments and everything are back in the U.S. segment. The teams here in Mission Control doing a great job, as just like the astronauts, they train for years and years to be able to do their job. So they know exactly what to do, and they're going to continue looking at everything. They're going to get them back over to the U.S. segment as quickly as they can. But again, crew doing fine, a little bit of an off day, but looking like not a problem, just a little bit of a false alarm. Someone's following along, though. I like that. That's great.
Yeah.
All right, next question.
Hi, my name is Dave Dawkins, and my question is, how does NASA tell time when the ISS is in space?
Great question. So if you think about it, we're going around the Earth there, and we're not really in any one time zone for very long.
And a lot of time zones.
Every time zone. Every time zone. We're doing laps pretty quickly. So we use a couple of different times to go through and help us out. So one of them is mission elapsed time that we go through and track with. So we say, hey, we launched at this time. How many hours has it been since we last left the Earth? Another one we go through is phase elapsed time, or PET. Would be going through and saying, all right, we're going to start this activity. So that may be a spacewalk. It may be a specific section of the mission, like a docking event or some other thing that would go through and say, hey, this is how long we've been in there. Another one would be Greenwich Mean Time, or GMT, which allows us to go through and say, hey, there's one spot in England, and that time is going to be kind of how the standard that all of us use to go through and measure there. It's really important to go through and use a consistent one for folks on orbit to go through and say, all right, so when we go to bed, we can go through and do there. And they'll shift around some for different events, because sometimes they want to be during the day here in Houston. Sometimes they want to be during the day in Russia, especially if they're doing a launching or landing event that they want certain lighting conditions for, or if they want to have certain lighting conditions on orbit or certain things there. So they can manipulate it some back and forth, and sometimes you need to hop between Houston time and the mission time. Yep. Because really for a lot of folks, going through and saying, all right, are people going to be awake at that time? What time do I need to come in? Because most of us here in Houston don't think in our day-to-day lives in that way, but when we walk into this environment, we really do have to go through and think about how they are in orbit and less about our daily lives at home.
Yeah, I mean, so there are 3 different shifts here just in Mission Control Houston that actually kind of structure themselves around the crew's day, which they follow that GMT time. So the first shift in Mission Control Houston actually comes in around 11 p.m. or midnight every single day, and that's when their workday starts. So it can be a lot of pretty crazy overnight hours for some of these people, but that's because that GMT, that's that Greenwich Mean Time, that's that zero time, if you look at time zones and everything, and that's the agreed upon time that we have, that we follow for activities, our colleagues in Europe at their control center, and Russia at their control center, and also Japan. So massive time differences. So we all kind of need to agree, okay, we need to just follow this one. It's going to be some rough hours for some people, but we make do, and it hasn't been an issue, and it makes scheduling everything a whole lot easier.
Okay. All
right, next question.
Hi, I'm Julius Francis Carter, and this is my question. The Orion spacecraft is designed to take astronauts and humans further into space and other planets. Will you have to design the spacesuits different because of this?
Great question. The answer is yes. So we always try and design around where we're going and what we're doing. So what you're trying to do does absolutely change where you go with the suit. So the big thing for us right now with looking at going beyond low Earth orbit, it changes the amount of time that if there's a problem, how long we have to be in the suit if we try and come home. So right now, if you're on ISS and you have to come home, you can really be home in a few hours. It's really not a huge amount of time. If you are on the far side of the moon, or you've just left to go to the moon, or you've just left to go to Mars, the amount of time you might have to go through and spend in the suit to come back becomes a real big driver. So that's one of the things we're looking at right now, is that if you had to be locked up in a suit for 6 or 7 days, what happens? And it's funny because we can get food and water in there, but it's getting rid of the waste products that come back out. Is how do you go through, and how do you go? You're in this little sealed up volume inside a suit, and coming back inside the vehicle, it can get pretty gross pretty fast.
Wonders of spaceflight sometimes.
Yep. So that's the big one there. So, and also if you're going inside, staying inside the vehicle. So some of our missions. So if you go look at like when we went to the moon the first few times we went to the moon, Apollo 8, Apollo 10, when we went through and did some of the testing out there where we actually flew by the moon, we actually didn't go onto the surface. We didn't land all the way. We didn't go out of the vehicle, and so we didn't have a suit that would go out of the vehicle. But we still went there to go through and improve the systems out. So if we did something similar in the future, you'd have a suit that could go help you get home, but wouldn't necessarily walk on the surface. So you'd bring different suits for those jobs. And right now we're working mainly on the suit that would go through and take you around, and not so much on the suit that's doing the walking is not included in that plan. So the Z2 would be the one that would be kind of walking around, and the suit I'm working on more is the one that stays in the vehicle, and if there's an emergency outside, we may try and go out and fix something.
All right. Let's keep the questions going.
Thank you. My name is Haley, and I want to know, will we be able to live a healthy and long life in space?
Great question, Haley. A lot of really smart people have the same question. So what we've got up to this point is we actually have a real interesting study going on right now, or just getting ready to start in 2015 here with the Kelly brothers, to go up and try and look at what does long-duration spaceflight happen. So we have twin brothers that are getting ready. One of them is going to stay here on Earth, and the other is going up to stay on station for 1 year. So looking at the differences between two very similar people. I mean, so twin brothers, how much more similar can you get than that in terms of, you know, their life and what their genetic code is very similar, and getting to see what that exposure to space for a long time is. We really haven't had anybody in 0G for more than about 534 days is the record for one of the Russians.
I think that's roughly the record. There's been a couple of people, there are 4 Russians who have spent longer than 12 months or longer in space at any one time. But I mean, some of the stuff that we've learned, so our astronauts on the station now go there for about 6 months, which is still a significant amount of time, and it's long enough for your body to start to adapt. That's one of the great advantages and disadvantages of the human body, is we adapt very quickly, which is great, you know, when you're evolving to harsh conditions down here on Earth. In space, it can actually kind of work against us, because you start to lose things. When you're floating around in microgravity, your body says, well, I don't need these legs anymore, so you'll start to lose your bone mass, your muscles will start to wither away, and that can be really serious. It isn't so much of a problem when you're just floating around, because you don't really need your legs, but let's say you're going to Mars, and that flight is going to take several months, maybe a year or longer just to get there. If you arrive and you can't walk, it's not going to be much of a mission. So that's some of the stuff that we're really tackling. We're really learning a lot about on the station, and we've come up with some really great stuff. We actually have astronauts that come back now that are even stronger and have even more muscle mass in their legs than they did when they left. And a lot of that is the exercise that we have them do. These astronauts, I don't know about you guys, but if I had to exercise 2.5 hours every single day, I might go crazy. And that's what they have to do, just to stay healthy. So when they come back on Earth, they don't have to go through months of rehab. So we're learning tremendous amounts of stuff just from our normal expeditions. And as Richard was telling you, this 1 year mission coming up, there's going to be 1 American and 1 Russian. They're going to spend an entire year in space. It's a pretty long time. And we're looking to learn a whole lot more. All right, next question.
Hi, my name's Eden Rambo, and my question is, do you ever get nervous when the astronauts report a problem?
Do we ever get nervous? I think always there's a little bit of, oh no, what's going on? It's funny. I more work on the building of stuff is kind of where my area is. So I most of the time don't get to be the one operating the system or going through and actually using it. We try and create great things that the astronauts can find useful, and then they come back and tell us, hey, was this it or not? And so one of the older engineers always told me that when you design, build, test, certify something, and get ready to fly it, you only know how the designers think it works. When it goes actually in orbit and it's actually being used, you learn how things really work. And so sometimes our astronauts come back and say, hey, this works differently than you thought it did. And it makes us think very hard and go back and look and say, do we really believe what we've always thought we believed? Because it is different on the ground. We work really hard to simulate things in a way so that they'll match things on orbit. But we have to be very careful to go through and say that our assumptions change things. So like I normally assume when I go to turn a bolt, the bolt's going to turn. In space, that's not a very good assumption, because if I go to turn a bolt on the space station's a lot bigger than me, and every action has an equal and opposite reaction, and so the bolt, instead of me turning it, it's going to turn me. And so it's that kind of thing that when you have an expectation, it's not always fulfilled. So we've learned some things recently about suits and how water flows in different places and where water moves around inside the suit that operate differently than we had thought for years operated. And it wasn't anything that the physics were all there to go through, and physics still worked like it was supposed to. It was really our understanding of what happened. So when somebody comes back and says, hey, I have this problem, we have to work really hard to go through and ask every question of like, well, do we really know what we think we know?
All right, next question, guys.
Hi, my name is Carson Russo, and my question was, do you think a man will ever step foot on Mars?
Great question.
Absolutely.
Yes. Yes. We don't know exactly the time, the date. We don't have it scheduled right now saying, hey, this, 2013 or 2017, 2018, we're going there, but that's really why we're here. This is what we do. This is where we want to go, is to go through and explore. So. Yep.
I'd echo that 100%. We will definitely walk on Mars. All right, I think we got time for one more question.
Thank you.
Hi, my name is Isabella Hoover, and my question is, how big is the Orion spacesuit, and what does it have on it?
How big is it? Great question. So it's going to be your size is the answer. We're really building these suits around the people themselves. So when we did shuttle, we were doing a lot of suits with off-the-rack kind of sizing, so we can kind of fit people into standard sizes. With smaller crews and less mission durations, it really makes sense to go through and more tailor things down to the individual astronauts. We're going to try and go everything from a first percentile female, which is a little under 5 foot tall, to a 99th percentile American male, which is about 6'6". So all different sizes. Great question.
Great question. All right. Unfortunately, that's all the time we have. So I want to thank everybody there at Bunker Hill Elementary for your questions. It's been great having you join us here in Mission Control Houston. I really appreciate it. Always good to see, again, people from my hometown. Richard, thank you for joining me. I hope you guys got some good answers. If you have any other questions, I'm just a phone call away, so just let me know. Thanks so much from Mission Control Houston. Good luck with the rest of the school year.